Welcome to Professor Russell Esposito's channel on information security. This video is just one of many video modules that are part of Professor Esposito's course on the subject. Video modules for his entire information security course are located on this channel. So remember to hit the like button as well as subscribe if you enjoy the video. Thank you for watching.
How is artificial intelligence used for cybersecurity? So there are a lot of vendors that are beginning to use more and more artificial intelligence in cybersecurity. One of the leaders is IBM. And in this presentation, we'll look at their 4 products. Again, these are not exclusive to IBM, but certainly IBM has a pretty good lead in AI for security. And it's all cloud-based, obviously. This sort of infrastructure, is in the cloud because it's complexity in terms of hardware and software. So these are the 4 products. We're going to talk about Watson Artificial Intelligence, QRadar Advisor, which is IBM's SIEM. Remember SIEM? In earlier presentations, we talked about Security Information Event Manager, Security SIEM, and that's what QRadar Advisor is. And XForce is a repository, really, of all of the malware and attacks. They're categorized. This is all the information they're collecting from their customers, how problems are resolved, and it's sort of displayed on a website that is sort of like a dashboard that lets you pick different topics and categories and drill into the problem. And Iris is the incident response service. So if you want to contract for IBM to have an incident response team, or if you have no contract with them, you can actually call them up if you have an incident and your team can't handle the attack, whether it's ransomware or APT or whatever it might be. You can actually bring IBM into the event and pay them to help work the problem. So you can contract with them, you can have a contract, or you can just use them if you have a problem on demand, sort of call them in like for an emergency. A lot of these slides are from IBM. Some have been updated by myself, and a few have been added. But this is IBM's view of what they call cognitive computing and artificial intelligence. And let's look at the steps in terms of the hierarchy of artificial intelligence that is laid out by IBM, and a slide or 2 from others. So let's start at the bottom of the slide where IBM lays out sort of the history on a continuum of artificial intelligence. So AI or artificial intelligence is really a very broad category. There are subcategories that are evolving and developing over time. So as you can see, around 1980, 1990, we began to see machine learning, which is actually, the beginning of artificial intelligence. And then to the right, they have cognitive computing. Some call this deep learning, but this is really, truly strong artificial intelligence. And if you look at the pyramid up above, it's a similar layout. These are stages of artificial learning. Machine learning is sort of the lower level stage. And then as you move up in the pyramid, you reach cognitive computing, or as I said earlier, it's also called deep learning. And that's where IBM believes their Watson AI computer, that's where they are in terms of maturity. And that logo with the sort of round globe and the stars, sparkles coming out of it, that's the logo for Watson. You may have seen that on commercials. And then above it, they have what, sort of aspirational machine consciousness, which I think is kind of controversial. I'm not sure anybody really understands. Will an AI machine be self-conscious? Are they going to have consciousness and have self-awareness? I don't think anybody really knows, but they have it at the top of the pyramid in any respect. That would be the ultimate, the ultimate pinnacle of artificial intelligence if we have reached that. And then the left-hand side, there's a square, and it's got more like it says demystifying artificial intelligence. To me, it sort of looks more like components and applications of it, of artificial intelligence. So there's natural language processing, which actually you have now in Microsoft Power BI, in their BI tool, which is not that expensive. You can say which region had the highest sales last quarter, and it can understand that natural language and pull up some numbers and perhaps a chart based on that natural language. So they're beginning to get into that sort of natural language with machine learning with Microsoft Power BI. But these other components, robotics, obviously, AI would be very valuable in manufacturing and other areas, service areas potentially for security. There are also robots being looked at for military use purposes, and obviously drones are robots as well. And then computer vision, that's beginning to take place. I know Google is experimenting with 6-foot distances between employees, because of COVID. So they have some cameras and some sensors and screens, big monitors in the hallway. So when people pass each other, they look up at the screen. They can see if the screen will indicate with red circles, around them on the floor that are superimposed on the screen. They're not really on the floor, but they can see if they flash red, it means they're too close to the person that they passed. So that's starting to happen. Computer vision, and certainly facial recognition is becoming more and more common and huge in China. And there pattern recognition, etc., deep learning and data mining for finding correlations that you might not think of initially, and different kinds of reasoning and human kind of intelligence. So that's sort of a high level overview of artificial intelligence. So I added the screen because I think it does sort of reiterate and reinforce the concept of artificial intelligence being the broader category. Machine learning, is a subset of AI and more sort of specific and powerful. And then you get more powerful towards the center with deep learning, which is really what they call cognitive computing. And that you hear the term neural networks, and that's what deep learning is. Deep learning uses neural networks to simulate human thinking and human decision making. And then also, if you look at the machine learning, sort of in the middle of the slide to the top, machine learning is what it is. It needs a lot of data. It needs some supervision or some instruction, and then there's unsupervised learning. It begins to learn on its own without being explicitly programmed to advance its understanding of the situation or what it's trying to interpret. So machine learning means the machine is learning. Again, you have to feed it lots and lots of data, set up models to help it understand what to do with the data, and sort of initiate that learning process. And then it begins to learn on its own and get better and better as time goes on, as it has more data and more time and more experience with the model and the algorithms. Now that we've gone through an overview of artificial intelligence, machine learning, deep learning, cognitive computing, this is IBM's several slides coming up that sort of teases apart an example of how a question gets broken out by Watson. Again, here's the logo of Watson on the bottom right-hand corner of the slide. How it teases apart what the problem and how it processes the problem and comes up with a solution. And it's a pretty simple example that they provide here, but I think it's noteworthy to go through, which would give you a little bit deeper understanding of what's happening under the covers of Watson or any cognitive computing or deep learning machine. The example that IBM provides is a question. Which Explorer 400th anniversary arrived in India, was celebrated in May 1898 in Portugal? So there's a lot of pieces here, right? So Watson teases the facts apart, as you could see within the red circles here. It's trying to look at that natural language and say, what are the salient pieces? What are the most significant salient items that it needs to sort of derive meaning for? So it teases the sentence apart first. So after Watson teases the natural language sentence apart into facts or salient pieces of information, it then looks for information about these different components. So some geography database, some time date or time database. It's looking at for other locations, Capac Beach. So it's going through and saying, what's the meaning of this? How do I put this all together? So it puts all these facts together after it gets some context for the facts, and then it comes up with the solution of Vasco da Gama, which is the name of the actual explorer, whose anniversary was celebrated, based on this event in 1898. We've gone through an overview of artificial intelligence, machine learning. We looked at how Watson teases apart a question or problem in natural language and comes up with a solution. Now let's look specifically at Watson artificial intelligence, how it's applied to cybersecurity. And this particular slide from IBM references this SASS component in their QRadar Advisor. So QRadar Advisor, again, that's their SIEM, that's their Security Incident Event It's Security Information Event Manager, SIEM, Security Information Event Manager. That's what QRadar is, but it works with Watson AI to give you the best solution. And they're referencing, for those who are interested, a specialized kind of cascading style sheet that's called Syntactically Awesome Style Sheet, SASS. I didn't want to leave this slide out because I thought for those folks who want to get deeper into artificial intelligence, this is another little piece of infrastructure within Watson that you might find interesting if you want to do some other research on your own. This slide sort of answers the question, how does Watson get its intelligence? So first, from the left side of the screen, it's an ingestion of different kinds of data. And we'll see in other slides, what these kinds of what the kind of data it is that it's ingesting. But there's lots and lots of data. The more data, the better for artificial intelligence, right? The more data, the better. There's some sort of classification, normalization, structuring that's happening with that data. Obviously, it's got to ingest this raw data, make some sense out of it, put it through a natural language processor so it can be used, input and output with humans. There's training and learning. That's, again, lots of data goes into it. There are some models that have to be built, and training, supervised and unsupervised training, and then obviously some output, which they call knowledge graphs, or as they pertain to cybersecurity in this case. So let's drill a little bit deeper into where Watson gets its data from and what it does with it. So it ingests lots of data, and if you see here, this particular slide discusses structured data, and it's ingested every 5 minutes, and a lot of it comes from its XForce exchange, which is that product, that database, and a dashboard that's available to the IBM customers who use their security products. So all of that data regarding their attacks, thousands of customers who have attacks, who have responded to attacks, they have categorized and they put into this XForce exchange for anyone to look at. Of course, you have to subscribe to it to really get deep into the data, but we'll see that some of it is available at no cost on the website xforce.com. But that data comes into Watson from that source and from other sources that it sees as structured cybersecurity data. The next source of data for Watson is unstructured data. That's cybersecurity based. So this is unstructured data that comes from the internet, and it updates. Watson's updated every hour with this unstructured data. And again, it looks like it's from the middle of the screen here. You can see it speaks of blogs and websites, news, all this unstructured data regarding security that comes from the internet, in addition to what they're pulling up from their own products like XForce. So XForce is the structured data regarding cybersecurity. This is unstructured data as the Watson crawls through the internet to look for any data that is related to cybersecurity. The final part of this ingestion process is really sort of structured and unstructured data that are best practices regarding cybersecurity. Recent attack reports, databases, the system. Watson crawls through the internet looking for best practices, and every 1 to 3 days this data gets curated and input into Watson to complete this process of consuming structured data from XForce and other sources that IBM may have, unstructured data from the internet, that's the center of this chart, and then to the right, best practice data from other professionals, other organizations and governments that have best practices on the internet, that this data is then curated and added to the Watson database for its AI purposes. This slide sort of categorizes a bit of a refresh of the other slides, but certainly there's unstructured data, there's obviously structured data going in. In the middle of the slide, they give you some of the types of formats that are being input, like PDF, doc, HTML, videos, etc. And then the bottom, they speak of recursive web scraping. So essentially, when they scrape the internet, when they're scraping a website and pulling out data, there's a way to keep that context. As the data gets scraped deeper and deeper and the system drills down into its scraping into a website, it obviously keeps some context of that scraping, so that there's some continuity and context of all of the layers as it drills down into a website, pulling up information. And they call that recursive web scraping, so that this relationship among these different data components in the drill down while its scraping is kept intact. This slide provides an example of how natural language processing within Watson takes a particular piece of malware called Locky, L-O-C-K-Y, and consumes the different components or different properties of it. The malware, the functionality, the behavior, what the rule is, and then builds some reasoning about how this works, and then puts it in a relationship database on the right-hand side of the screen. So it's consuming this data, again, breaking it apart, and storing it in a way that it can reuse, that Watson AI can reuse. The security industry has a sort of a programming language called STIX, S-T-I-X, Structured Threat Information Expression. And it helps standardize communication and helps create a standard representation of a cyber threat. So this slide is just saying that IBM is using STIX, S-T-I-X, to help define and categorize the data that's coming in. Some of it might be in STIX format, some of it might not be, but before it puts it into its database, it's going to break it out into the STIX format, the STIX expression for storing it into its database. NIST, the National Institute of Standards and Technology, they are working with IBM and others to create a standard artificial intelligence framework that they hope to have the standard framework around the mid-2020s. And this slide is just showing that there's ingestion of information and new learning. There are SMEs. SME is the center of the screen here. It's a subject matter expert. So you may hear that term in a company, particularly one that's either a department working with IT or the IT department itself. They'll look for SMEs, subject matter experts. Sometimes these are business people who work with IT to help design systems. SMEs, they'll call them. So there are subject matter experts and other researchers. They go through training and more education, and there's an evolutionary process that is taking place throughout the industry to improve upon artificial intelligence and how it's used within cybersecurity specifically. We covered artificial intelligence, machine learning, deep learning, or cognitive computing, as IBM calls it. We looked at that sort of the introduction of these subjects and the concepts, and then we looked specifically at Watson artificial intelligence and how it works and how it's consuming data for cybersecurity in particular. And now this next set of slides is about IBM's QRadar Advisor, and this is their SIEM, their Security Information Event Manager. The SIEM is a reporting system, as we talked about in an earlier presentation, and it works with Watson artificial intelligence to provide the best solutions and the best information about cybersecurity before an attack and after an attack. So let's take a look at how this SIEM works and it benefits its customers and how it benefits its customers. So this first slide covers the first step in QRadar in its process. So it's the ingestion. It's the red box that's circled with the blue highlight here. The focus of this slide is the ingestion of the data from the client. So QRadar Advisor is at some site, a client of IBM, and they're consuming all the firewall data, all the logs, router information, switch information, significant servers. It's getting all this data and log information into QRadar. It's curating it, it's storing it properly, it's beginning to make some correlation, and that's the first step in the process of how QRadar works, consuming the data from the client. And you can see at the bottom of the screen there's the SOC users, the users of the system, the Security Operations Center, and you'll see how they get engaged further on as this process continues. This slide illustrates how IBM QRadar Advisor, the SIEM product, works with Watson AI, and the center of the screen has that yellow highlighted area, and an arrow points to the cognitive analysis. So now it's getting more rich information, global threat intelligence, all the information that Watson artificial intelligence has, and it curates that along with the data that it's been getting from the client's security infrastructure and other servers and logs and information from the customer's site that's consuming data from that first step, the red box to the left in the previous slide. And you can see down further below, and the previous slide had this as well. It had the SOC team, the SOC users, the Security Operations Center. So these tier 1, tier 2, 3 analysts are beginning to see information about the threats and what's happening, and if there are false positives, or if there's a positive attack that has to be monitored and there has to be some intervention. It's beginning to get this sort of level of higher intelligence to the SOC team as QRadar works with the Watson AI for cognitive analysis. And this slide focuses on the incident response, the QRadar output, the green box to the right. So now you're getting the final reporting in totality that there's a problem. And now if you look to the bottom on the right hand side, incident response team from the SOC users or the SOC team, the incident response is now getting involved because this is a clear attack. There's something going on. Either it's a reconnaissance that's active or some other step in the chain of events that leads to an attack or a final infestation or installation, I should say, of malware that's going to either be an APT, an advanced persistent threat, that steals your technology, your trade secrets, whether it's military knowledge or military technology or big pharma, pharmaceutical information or other scientific information. Then now there's a response that's happening as a result of the QRadar output from that right highlighted box to the right. This is sort of a summary process slide for QRadar Advisor. That's the full name for QRadar. QRadar Advisor is this SIEM, this SIEM from IBM. So this really just shows you the cycle, the data from the customer, the logs from the firewall, the IPS, the IDS, the routers, all that security information goes into QRadar, and then it passes it to the Watson AI, which is in the cloud. If you notice in the bottom right hand of the screen, the slide here, it says software as a service, SaaS, right? Software as a service. It's in the cloud, is what that means. And then the data goes back to QRadar for this final reporting that benefits the SOC team, and they act on the final report. So this is essentially just a high-level review of the process. QRadar to Watson AI, back to QRadar for final reporting. And this is a sample screenshot of a report that the SOC security operations team would see, the SOC team, in terms of a concern score for a particular event. And if you look at the left-hand side, you see the scores of very, very high, 0.99, down to very, very low concern, 0.1. And it's just really a sample of one of the kinds of reports you get in terms of the way an event or an attack is scored, so the team can respond appropriately based on the score. The two other products that IBM offers is IBM XForce and Iris. XForce is a database of a knowledge database of all the malware that's out there, the kinds of attacks, how they're being responded to and resolved by all the IBM customers. And Iris is their incident response team. Again, it's a service that you can use to help you, to get them engaged, to help you to resolve an ongoing attack. So let's look at these a little bit more detail. So IBM XForce is a product that you subscribe to, and essentially any activity that any IBM customer has subscribed to XForce is recording any malware, any adverse attacks, how they're resolved, what they've seen, the dynamics of the attack. It all gets recorded in this dashboard or this database essentially. So it's a global threat database, and there's this dashboard that's available to customers. If you go to XForce, you can actually, xforce.com, you can actually see some of the data, but some of the data requires a login. But it gives you a sense of how this data is curated and stored and correlated or organized, I should say, and displayed on the XForce dashboard. But it's really a repository of threats and malware and attacks and how they're being managed. You could also put in this search box on the screen in XForce, you could put a URL and it'll check the URL for any problems that the database may know about, or you can even put a file there and it'll review your file and it'll give you an assessment if the file has malware, at least known to the XForce system. But it's a global system. It's pretty comprehensive. The final product is Iris Vision. So this is an incident response service. And it works, in tandem with XForce because it's going to rely on a lot of the information from XForce to help resolve a problem you're having. So you essentially contract with Iris to be to help or be your response team, incident response team. So if you have a cybersecurity attack, Iris would become engaged. Obviously, they have access to your system environment and your network environment, and they can help control and eliminate the problem. You also don't need to subscribe to Iris. You can just know it's there, and you can contact them if you have a problem. So this is sort of an ad hoc, on-demand service as well, whether you contract with them or not. But if you do not want to contract with them, but you can certainly have them engaged if you have an attack on an ad hoc basis or on-demand basis, and contact IBM to get Iris involved. Of course, there'll be a bit of a startup. There'll be some time for them to actually get engaged and become more familiar with your organization, because this is just happening on demand in an instant, as opposed to if you have a contract with them, they'll be more up to speed with your environment and have the right connectivity that's already in place. But that's the final product that IBM offers. I think there's one more slide on Iris. We'll take a look at that next. So this slide highlights that it's a fast response from an expert team. Obviously, they've got all the IBM tools and knowledge and expertise that they could bring to bear on your problem. And again, it works with the XForce database and repository, so that they have that information and that sort of knowledge base to work with to better understand your attack. It might possibly be in that database. There may already be a resolution. They may have had other customers that are already lived through this, and they could sort of gain knowledge, gain the benefit from having that knowledge from another customer who's had the same experience or a similar experience with the malware attack that you're having. This slide has 5 videos. The first 4 I think you really should watch. The 5th one is optional. It's kind of lengthy. It's 32 minutes, but it's a really good slide at the RSA conference, which is RSA obviously is the company that created the original RSA asymmetric encryption. And the SANS organization, SANS, is a very professional organization of cybersecurity experts, and they have different levels of certification as well. So SANS is a very well-known cybersecurity organization. I think it's a good video, but if you have time, it's not required. The first 4 videos you really should watch. The first 2 are generic about machine learning, not specifically as it applies to cybersecurity, but just I think it'll help cement in your mind how machine learning works and pieces of it. And then there's a video here. The third one is on Amazon AWS machine learning. Their product is called SageMaker. It gives you a sense of the sophistication that's available to really anyone who wants to subscribe to these services. You don't have to start from ground zero. You can use Amazon or Microsoft Azure or IBM. You can use their infrastructure, their software platform, build your model there, put your data in there, and start working with ML, machine learning, to help your organization with whatever it is whatever problem you're trying to resolve. So that's the beauty of working in the cloud, because you have this platform, this infrastructure ready to go, and you just plug into it you have to go through some training, obviously, develop your models, plug in your data, and you're up and running with machine learning, which is a fairly sophisticated step in the world of artificial intelligence. And then there's another video here that I have. It says how AI and ML will transform cybersecurity. At least start at 21 minutes 30 seconds. From 21 minutes and 30 seconds to 31 minutes, it's all about cybersecurity and machine learning. The first 10 minutes you don't need to watch, but if you want a nice review, it's a really nice review at a high level of cybersecurity in general. So what this video does is spend 10 minutes laying out the foundations of cybersecurity in general, some of the things you've been learning during this entire course. So it will be redundant, but if you want, it's a nice quick review for 10 minutes of some of the highlights that you've already gone through. And then the last 10 minutes of the video is really about machine learning in the cybersecurity world. So enjoy those videos. I think they'll be educational for you. So this concludes our module on artificial intelligence and cybersecurity.